So with that, I'm gonna start with multiple choice, and I think. Oh wait, this is being your first time to assessment for this class. I probably haven't had chance to say this. What I'm gonna do right now for the next 10 minutes is cheating. You should not be doing it. So I'm not really demonstrating anything that anybody should do. During the timed assessment, no outside help is allowed. There may be some very limited things you can use, basically calculators and dictionaries. That's it. Anything else that you're using that's not part of the course, Perplexity is not part of the course, ChatGPT is not part of the course, Check is not part of the course, because they are considered outside help. Any use of that during the timed assessment is cheating. So please don't do what I'm gonna do. I'm doing it as a not as a demonstration of what you should be doing, but more as a me keeping up with the cutting edge of what's out there available, something that's easy for people to use. And what I will say is that there is a way generative AI can be used in an academically honest way. And I would say that way is to use generative AI after you've done the questions. And so, so let me demonstrate kind of in an opposite way. As I'm going through the multiple choice questions right now, I'm going to use generative AI. That use is it's cheating. Don't do it. After I'm done with that, I will explain in what ways someone could be using generative AI in an academically honest way. So let me first cheat my way through. Let's see what it does. I wouldn't actually, at this point, I wouldn't be surprised if ChatGPT gets 10 out of 10 right. It's gotten really good. And Perplexity is better than ChatGPT. So for the next, I don't know, 5 minutes or so, I'm just gonna basically turn my physics brain off and just focus on copying, pasting, copying the answer back, and all that stuff. So work by selectively. Okay, so what's the correct choice? I'm just looking for that. I'm not really thinking about physics at all. And I've gotten into habit of not doing A, B, C, D so that to save time. But I think maybe I should have with that question. Oh, wow, that's gonna take so long. Uh, so what's the answer? Um, like cheating to my desk. By selectively, that's none of those choices. Uh, Statement that is trans is what? So what statement is accurate? So linear explanation. What? Okay. I guess maybe I should be happy with the fact that okay, I can't tell which of those are which. So let me just do it this way. A. I mean, I should be happy that it's getting harder to cheat with perplexity. I'm just upset that it's messing up my demonstration. Uh, so what's the answer? Correct X. Okay, B. All right. Okay, don't need the rest. um, so here I actually have to type this in. So a. Oh, I need to copy in the image description. Image description. And n is equal to 1.33. N is equal to 2.42. C. N is equal to 1.42. E. N is equal to 1.92. E. N is equal to 1.51. I think I wasted a lot of time. 7 minutes. Yeah, I gotta go faster. So while it's doing that, let me copy and paste this. It's taking so long. 1.92. Okay. I have no idea if that's right or not. I wasn't thinking about physics. Let's see if it gives me an answer that I can just copy and paste easily. If it's not doing that, I might have to start putting back ABCD. So blue light has, okay, I think it's saying blue. Oh, yeah, okay. All right. Real image different from virtual image. Oh, yeah, I think I can think about it. Let me just check the time. 6 minutes. Yeah, not a lot of time left. Gotta go faster. Yeah, well, okay. So I think something has changed in Perplexity where it does not give a useful response if I don't put this ABCDs. So I'm gonna go back to putting in ABCDs. Which I guess I should be happy because someone who's cheating with the perplexity would find that wastes their time, makes it less likely that they can get high score using perplexity. See, okay. A, B, C, D. Oh, I think I'm gonna run out of time. Yeah, it did that, answered all that. B. Okay. Oh, but I think if you put in ABCD, then it's fairly quick about getting you the answer. So I don't think whatever modification they may have made, I don't think it was made with the intent of stopping people who would cheat with perplexity. 'Cause I think it's actually giving a much shorter answer when it realizes it's answering a multiple choice question. How much time do I have? I have 4. Okay, maybe that's enough time. See. Alright. A, B, C, D, E. Alright. Come on, give me the answer. None of them? One? Correct answer of them. Alright. I'm pretty sure perplexity is wrong. So it's gonna miss one. I don't know. I can't tell you exactly in what way it's wrong. Because again, I wasn't thinking about physics. I was focusing on cheating. Um, Again, you shouldn't focus on cheating. I'm just doing it for fun. As test student. What's the answer? 7.6. Oh yeah, that's the setup I was describing earlier about with the conceptual questions, how you can get kind of um, Earth-sized baseline that will give you very high resolving power without necessarily giving you a large amount of intensity because you don't have an actual Earth-sized detector. Let's see. All right, so those are all the answers. I think I have a couple minutes. Probably not enough to double check all the answers, but let me just check through the ones I can. So, how does linear polarizer work? Absorbs light. Yeah, I think that sounds right. So that's probably right. Consider what's the small such prism can be made out of. Yeah, it doesn't have to be in water, right? Uh, so I think it just Purplex just missed it. I think it's like n equals 1.42 or something. It's not like 1.92. That's above most above like you need some special transparent material for that. So I think Perplex got 2 right so far, or let me count the ones it missed one so far. uh, Real and virtual image, they're different because yeah, this is wrong. So so Perplex missed 2 so far. Plano convex is converging. Okay, that's correct. What type of nearsighted person? I think that's right. Laser is coherent. Consequent form stable. Yeah, I think that's right. And I was saying this is definitely wrong, right? So 3 maybe. I gotta. Well, yeah. Let me just. How much time? Okay, 1 minute. So here it probably got it right, and it probably got it right. So I think it missed the 3. I can be more thorough after the time limit runs out. 40 seconds. Actually, let's do that. So I think it missed at least 3. Let's submit and see if we missed this additional questions. All right, it missed exactly 3. With the calculation, Perplex has been getting good. That's why I thought I probably got it right. So let's look at the questions and make sure that I got the correct wrong ones. So this is the context where I would tell you this is how you might use generative AI in an academically honest way. So as you can see here, and you have 3 attempts on your multiple choice. You should use all 3. System will count your best attempt. And in between your attempts, I do recommend that you study. So part of the studying is reviewing your work, what did you miss, and so on. And as you do that, you will see the system doesn't tell you what you got wrong. So that can be hard. And I think in this, and I have a reason for setting the settings that way. I didn't want people to be able to just get a bunch of answers, and like the kind of tends to defeat the question pool that I'm using. So that's why you don't have access to answer key until after the submission due date, next coming Monday. So as you're looking at it, if you're not sure if you got this question right, one of the things you can do is you can ask it of ChatGPT, like a question here, and read its response by selectively and so on. The selection is achieve different mechanisms. Principle is the same, polarized, yeah, absorption mechanism. That's, I guess, one of the ones that they were talking about. So if as you are reading it, if it makes sense to you enough that your answer was right, then okay. So that's not one of the 3 that I missed. And then we move on to question 2. And here, if you're not sure, and if you ask Perplexity, then it'll have given you wrong answer. Why did they think it was in water? High quality. Yeah, all these are fine in case of pluralism, infraction of air. Okay, that is actually right. So too. Yeah, I don't know why they're getting to water. Because you should just use it for in air. So as you are reading through it, you kind of say, okay, these methods are right. The only part there it missed is it set n2 to be equal to 1.33 when it should have been 1. So then, so the critical angle is, I think, 45 degrees. So turn it around. N1 is 1 divided by sine of 45 degrees. Let me do that in Wolfram alpha. 1 divided by sine of 45 degrees. I hope it gives me a decimal approximation, or 1.414. So then you realize, it should be 1.42, greater than this index of refraction. And this is met by a lot of acrylic, like acrylic that you saw in lab, and glass around the 1.5 index of refraction. There's comfortable margin there. Good. It just wouldn't work in water, which, You shouldn't be dunking your binoculars in water, which is higher frequency. And this one I think I got it right, so I'm gonna move on. How is real image different? So again here, if you had asked ChatGPT, then I think it would have given you wrong answer. How is a real image different from virtual image? That absolutely cannot be used as an object for the next stage. That's also wrong. I don't think Perplexity really understands multi-stage lens setup well. So yeah, so I don't know what can help you here, where Perplexity is simply misinformed about this. What I will tell you is, so real image formed on the same side as the outgoing light rays. This is actual like verbatim the sign convention rules. So that is the correct answer. Virtual image is formed on the opposite side as the outgoing rays. And I think the rest is probably, this is just the wrong version of this. They're both wrong. Multi-stage setup, real image earlier stage can be, and that's what I say. Virtual image absolutely can be used as the object for the next stage. So okay, so that one is a wrong one. The correct answer should be A. So far two. The lens shown in the figure below. I think I said it. Got it right. Got it right. Oh yeah, question 8. That's the odd one. It gave me a whole bunch of stuff that. So let me just think about the question. Okay, thin oil film lying on top of water. Okay. Index of refraction was increased. Okay. How would the first pattern change? So the reflection at boundary conditions, they remain the same because the oil being higher index of refraction than water hasn't changed. So I think the only thing with the change is with the higher index of refraction, the effective thickness of oil film is thicker, or when you count in terms of number of wavelengths, the more wavelengths would fit. So it's like having a thicker thin film, which means spacing between the fringes would, I think, get thicker film would get narrower, I think. Intensity, if anything, would increase with a greater difference. The reflection coefficient is larger. Spacing between bright fringes. Yeah, this can never be right. Either they both get broader or both get narrower. So let's see why Perplexity missed it. Difference, constructive, condition for the optical path difference, which is thickness film, wavelength of the light, and this part. That's what we are changing. Increase optical path length. Okay, so far so good, right? Shift the positions, Do not, doesn't have to. In fact, a lot of my multiple choice questions, the correct choice, I try to write it in a way that sounds wrong. Actually, this is wrong. Phase shift upon reflection, if you compare the numbers, you'll see, there's no change in the phase shift. But there is this, which could alter conditions, potentially change without specific. No, you don't need the specific details in the thickness of the film, because whatever it is, it's fixed. And with the increasing optical path difference, the spacing should get narrower, I think. It changing the. With the multiple choice, if you don't see the one that you are looking for, choose the best one. That's what you should be doing. So I think that's it for that. Let me do this. So I said at the beginning of the session that I'll take about 5-minute break after about 45 minutes or so. So let me do this multiple choice demonstration just one more time. I'm competing with the ChatGPT, so I'll do it with a calculator, but no Perplexity, and let's see if I can do it faster and more accurately than Perplexity. With the calculation questions, that could actually be a real competition. Who can do it faster and accurately? So I'm gonna do this. I'm gonna wait. I'm gonna return to. I think if I just refresh, I'll get an option to redo it. So yeah, let me retake it, and I'll just do it myself with maybe calculator, no cheating. Let's see who does better. Retake. All right. I've seen this question, and that helps me because before, when I saw this question, I worked out the numbers and I said it should be 1.42. So I'm gonna answer that and then move on. A fish looks up at a sky. Oh yeah, this is a fun picture. What is the approximate angular size? Oh wow, that is a difficult question. I'm gonna skip it for now and come back. It might be this, but I'm gonna skip it for now and come back. And I think this used to be a homework question. That's why I felt I could ask it. But right now, now that you don't have a homework question like that, that's a super difficult question. Linear plus line of intensity, something, linear plus axis. Okay, that's a calculus question. I'm gonna skip it for now. I'll come back. Object is calculation question. I'll come back. Image formed by single biconvex lens. That's converging lens. So it could be real and inverted, just not always. It could be virtual and upright, just not always. So none of the above, because it could be one of these two, depending on how far away the object is. It's possible to assign a focal length to a plane mirror. Focal length is infinity. Yeah, not zero, infinity. So, n-slit interference pattern showing several principal maxima. What is the, I think n value is 2. This looks like double slit interference. So, shows 3 principal maxima. There's one, yeah, that's double slit interference. Just that's random chance. It would be more interesting for n equals 3 or 4. Consider a double slit located. Okay, calculation, skipping. Oh, I think all the questions. Okay, not this one. Diffraction grading are the key features in this pattern. And monochrome primarily due to. That is such a vague question. Key features. I'm gonna say the main key feature is the principal maxima, and that I want to say interference, but the correct answer might be this. Let me just stick with the interference. Let's see. So okay, I gotta do the calculation questions. I have 7 minutes. Okay, so for this, I have to think of this picture. So the picture I'm thinking of is this is a water surface, and I'm down here. I'm an observer down here looking up, and there will be certain angles of light where as it hits here, it's at the critical angle goes like that. Critical angle goes like that. Or, you can reverse the direction and imagine this as incoming light to the observer who's here. So, so you can get this angle by figuring, okay, for what angle of incidence here would you get critical angle? So go through Snell's law, and water times the sine of this angle over 2, theta over 2 is equal to the air, 1, times sine of 90 degrees, 1. So I'm solving for this theta over 2 here. Or solving for theta, it should be 2 times arc sine of 1 over 1.33 for index of refraction of water. So with that, I calculate 2 times arc sine of 1 over 1.33 in degrees. And that's I don't get it. Never mind. Let me just do it that way. So it's gonna be an answer in radians, I think. So let me just multiply that by 180 divided by pi. So about 100 degrees, I think. Yeah. So about 100 degrees for angular diameter. We're on 5 minutes. Okay. Linear polarized light at 30 degrees, I'm using Malus' law, which says transmitted intensity is incident times cosine of the angle, 30 degrees squared. So 0.75, that one. Yeah. Okay. There. So that's a whole different set of thing. So I have an object in front of a converging lens. Okay. So I'm gonna use the thin lens equation. 1 over object distance plus 1 over image distance is 1 over focal length. And how far away is image form? Yeah. So di, just it's gonna be 1 over f minus 1 over do. So let me do that calculation in Wolfram alpha. 1 over focal length 18 centimeter minus 1 over object distance 2.1. Oh, I didn't actually have to do calculation, so it's gonna be virtual and upright. Let me see. So a virtual image forms I can only eliminate two. Okay, it's either 1.1, 5.1, or 2.4. Which is it? It is 2.4. The height, I think, of the object is it's irrelevant. It's a distractor. Okay, a double slit, 1.2 meter from the screen. Separation between slits is that. Okay, distance between bright fringes. So let me just make sure I have time. Yeah, 4 minutes. So this is the consideration I'm working through. The expression for the bright fringes in double slit interference is d sine theta is equal to m lambda, and with a small angle approximation you can say d theta is approximately m lambda. So the angular distance between successive m would be equal to lambda over d. Now it's not asking about the angular distance, it's asking about the distance, and with this L, that distance, delta y, under same small angle approximation, theta much less than 1, would be the distance, L, times delta theta. So it would be L times lambda over d. So let me calculate that in Wolfram alpha. That's L to 1.2 meters divided by, or times the wavelength 500 nanometer divided by slit separation 0.06 millimeter. And I'm doing it in Wolfram alpha, so as long as I type in the units, it'll just convert the units and give me 1 centimeter or 10 millimeter. So that should be right. Kind of doing it in a hurry, so if I don't get 100%, that'll be my excuse why I didn't get 100%. Diffraction grading has that many lines. So with the diffraction grading, two things that are useful to have internalized: that the position of principal maxima is given by the same relationship as for double slit. Same relationship as for double slit, which is that d sine theta is equal to m lambda for constructive interference. So all I have to get is d, which will be equal to, for diffraction grading, 1 divided by number of lines per whatever. So, and you can see that for d, if I put in these units, I'll get unit of length. So what am I solving for? I'm solving for theta when m is equal to 1. So let me just do that algebra in my head and just type in the numbers here. I'm looking at lambda, so 633 nanometer times divide by d, or times n. That'll be 2500 lines, not a unit, per centimeter. That should give me sine theta, so arc sine of that. I have a sense it's not a small angle, so arc sine will actually matter. What? Oh, okay. So, yeah, 9 point. Okay. Yeah, I don't know why it was getting confused. I think, yeah, but putting 1 centimeter on the bottom helped. Yeah, I don't know why before the wolfram alpha was getting confused. Okay, I think I answered everything and I got 27 seconds. So let's hope I didn't miss any calculation questions. If I did, again, it'll be embarrassing, but I'll go in, check which one I missed. If I missed anything, I might suspect question 10. That's probably the first question I would check if I didn't get 100%. So we'll see. So I didn't get 100%, and my suspicion is that it's with question 10. Question 10, no, that's my attempt number 1, right? Let me look at attempt number 2. So I would suspect the question 10. So let me do it this way. I'm gonna message instructor. Uh, is the correct answer equal share of interference and diffraction? And once I send myself a message, then this is what I can do. I can go into my open math, open that message, and check what the answer is. Assignment. Oh no, that was correct. What did I miss? Must be one of the calculation questions. Let's scroll up and see. Which one did I miss? It's I missed that. That doesn't sound right. Oh, I think I know what I missed. I put in 2.1 centimeter as, yeah, I got distracted by that. That's the height. I should have put in 1 centimeter for the object distance. So this should have been 1. Yeah. Again, as I kept half jokingly say, it will be embarrassing, and it was embarrassing. And the correct distance would be 1 point. So this would be the correct answer. A virtual image forms 1.1 centimeter from the lens. Yeah. Yeah, okay, so I missed one. In my hurry, I misread a number, and that's why actually that number is there to catch people like that. So be careful. This can be a pretty difficult set, and I think I've said the typical A student will usually get a score like a 6 or 7 or above. That's kind of, if you're getting score of 6 or 7 or above, that's actually a good performance. You got nothing to worry about. And I guess ultimately, none of these scores actually count for anything, so you know. It's more for you to test yourself. That's really the main purpose of this. So make sure you are testing yourself well.